Hello people, in this video tutorial I'm going to show you how to display the node and element numbers in the pre-processing and post-processing stages of the 3D Experiences release 2024. It also applies to earlier releases. Now this is a revisited topic because maybe 2-3 years ago I did some similar to that, but I decided to upgrade that and in fact include the post-processing stage in it. I call these things the not rocket science series because they're not complicated, but it can save you a lot of time because uh, uh, trying to get it from the documentation or online resources, internet resources, is very difficult. And I'll do that in the context of an example. The example that I'm going to do is a sheet like that, a sheet of steel, for example, and uh, I'm going to divide it into three elements, three four-noded elements, and clamp the left end and apply a pressure on the top. But that's really not the issue right now. Let me create the geometry. uh, I will come back to the follow-up video, follow-up slides later on. For example, the next few minutes, I'm going to show you how to generate those numbers is actually this slide. We come back to that later when it comes to reviewing it. All right. So here we are in the 3D Experiences platform screen, and we are in generative shape design because I want to create a surface. So, for example, on that plane, I will sketch a line which is 40 millimeters long. Okay, let me dimension this thing. 40 millimeters. Okay, exit, and then I'm going to extrude that, creating a surface. Extrude that in the direction. In the direction Y, right click Y by 120 millimeter. Good. Okay, so what I have here is basically this sheet. I haven't meshed it yet. Let's apply material properties to that. So we go to tools. Uh, we're gonna uh, we're gonna apply steel properties of steel. So for example, I'm gonna create one. Today is January 3rd, 2024. Steel. All right, and then we say okay. Right there. So we're going to apply that. Apply. Let me close this. Apply to that. And we're going to input our numbers. So basically, it's the Young's modulus for steel, abacus multiphysics, mechanical, elasticity, 200,000 megapascal, 123 MPa, and Poisson ratio of 0.3. A very simple elastic problem. Okay, we're done here. So now we're going to go mesh this thing. So I go to the top left corner in the compass. This is called the compass. And we're going to go to structure model creation, which is basically meshing. So empty mesh, FEM. Okay. And then here is my surface quad mesh. Okay. You click on it. You select that. Size of 40 millimeters. So remember, this was 40, this was 120. So there will be three linear, this is linear element, three linear element generated right there. Okay, if you look in there in the mesh tab where I used to mesh this thing, uh, and all the way to the right, you see something called numbering. If you click on the numbering, this thing pops up and it says that you can give me your range of node numbers and your range of element numbers, as long as, of course, it makes sense. Right now, you have 8 nodes and 3 elements. As long as you give me your range, I'm going to try to number the nodes and elements according to your range. But if you want me to use the default values, let me say initialize values. Notice that when you click on initialize, it says that 10 will work for both nodes and elements, so it's okay. So You can customize this thing, or you can say initialize values. So basically, this is what you see in here. Okay, and I got that guy. All right. So we say okay, and notice that in the tree, in the tree, you also have a numbering branch. Now, if I click, if I click on the screen, this guy pop up says numbering visualization. Numbering visualization. The difference between this and the previous numbering is that there is an I here. Okay, if you click on it, it's going to come back and say, hey, numbering is out of date. Can you update? Now, updating, you can do it by either Control U or go to the update icon. Control U will do. Okay, now notice that first of all, if you click here and you click on that, there's not an issue. Cancel. The other thing is that if you go into the display tab, that guy will also pop up in here. You can either get it from here or you click there and click on that. Now, so what I just showed you is uh, basically the fact that it said no, the numbering is out of date. Control U updated it, and now I get something that looks like this, not quite, because let's see what we got right now. So it says, okay, you want the element numbers, display the known numbers associated with it, and go select. If I notice, if I put the cursor here, it lights up. It says element 1. Okay, and if I select it, it also gives me node 8, and I can't read this thing because the background is white. So what I want to do is, first of all, change these colors, because white on white does not appear. So here's what I'm going to do. Notice that for a color label, you click on this. Let's use red. You say OK. This is for example, if I select this, notice that element turned out to be red. You can see that element is red. Okay, right there. Okay, and if for node number, you click on it here. For example, let's make it green and say OK. So notice that when I select this element, it says element number one, nodes 6, 8, etc. 2 and 1. Now, of course, it's possible to change the scale of these, the font size, but I'm not going to do that right now. We just go say fine. But there is an option. There's something we can do, and that is what okay, we can change the background color. So first of all, let's hide this extrude. See whether it makes a difference. Yeah. So let's try it again. Click there. Numbering visualization, select that. It's a little bit maybe better, not that much, but we can also change the background color. So right click ambient. So for example, blue, let's go to, what is that, blue design. And now click. That's a little bit better. 1, 2, 6, and 8, element number 1. If you do this, uh, element 2 between node 5, 105, I can read this thing, 8 and 6, etc. So what you're seeing is basically this screen. Now I want to go ahead and apply loads and restraints and run it, and then finally be able to look at the results and identify the element with the numbers on it. That is not straightforward, I can tell you that. So we say fine. So I'll keep the background color just like that. Let's go ahead to uh, structural scenario creation. It's the mesh that we created. Here, click on that. Uh, we're going to do linear static, so I expand this advance and uncheck the include geometric nonlinearity because I wanted to do it in one step, no increments, etc. So under the boundary conditions, we select this edge, and we say it's all restrained, so it's clamped, fixed displacements, all degrees of freedom or check. The only thing is that I can't select that point. Cancel that for a second. All right. So let's see. The reason I can't select it is let's see now. My extrude is hidden. Right click, hide and show. Oops, hide and show. Yeah. All right. So we go to fix displacements. That edge, 6 degrees of freedom, or fix. All right. And then we apply load on that, load pressure on this face, the whole face basically, of 0.001, point 0, sorry, 0.1, 0.1 MPa. And one thing I forgot to do to define the thickness of the shell. I will do that later. We can do that. Notice that if I want this thing to be pushing down, obviously I have to make this thing minus. It has to do with the direction of the normal to the element, but we are not interested in those aspects. Another video will be done for that. All right, so it's pushing down on this. The only thing is that I forgot to do shell the shell properties, shell section. So if you look at here, this is not done. So I can go back here, all right, back there, and on the properties, where is that shell section? 10 millimeters from the middle plane. I select the extrude. Okay, so I selected the extrude 10 millimeter, and we say okay. Let me do Control U, make sure there are no issues. Control U. Yeah, I don't see a problem. So back to the scenario. Back to the scenario. I have my restraint and the load is in the proper direction, pushing down. Okay, and that's pretty much it. So let's go ahead and run it. Under simulate, I'm sure this is going to run. I'm not going to bother checking the model or the scenario. I'm just going to run it. Take my chances. Although it's a bad idea. Okay, it's going to be a very quick problem. Only 3 elements. Okay, it's almost done. Okay, close that. And there we are. Incidentally, let me put the background color to white. I'll show you why. I'm going to change it to blue later on. So white mirror. Okay, fine. That's fine. Now, I want to find out what are these element numbers and the node numbers and things like that. Of course, I know what they are because I knew it at the pre-processing level. But I want to know it here too. First of all, I'm going to double click on this, and under the tab, third tab on the top, I'm going to say, show me the mesh also. There we are. Okay, that's great. Now do it again. Double click on this. Under the middle tab, it says show the node labels. You click on this, show the element label. Say okay. Now, I can see it. I can see number 1 here. Okay, and I can see number 3 here. Okay, but you can change but the element numbers I cannot see clearly. So if I go right click, change the ambient color to blue design, well, that's better. I can see that 3, 4, 7, etc. So if you rotate this one is kind of hard to see, but anyway, this one is 6. Okay, now there is an alternative of doing this thing. Instead of uh, doing this plot, this kind of a contour plot, I can go to let me first of all make this thing non-smooth. Double click on this, say non-smooth. It doesn't make any difference, so we can see that. But if you go on the plots, there's something, scroll to the right, there's something called uh, ISO contour plot. You click on it and apply. There we are. Except that in the middle one, I say I want to see the nodes and elements also. Apply right there. This is a lot better. So unfortunately, with the regular contour, unless you change the size of these, perhaps, because there's not much opportunity to change the color of these things as we did earlier. But the size of contour will give you the information better. So what I have done here, first I showed you in the white background. It's not going to come out very good. Then I changed the color, the background color to blue design. And then finally I said, okay, why don't we also do the ISO contour plot? Then you can see the numbers. Okay, so as I said, these are not rocket science, but somebody either have to show you or you have to dig it out from somewhere.